You are joining me for this video here on change of base logs, an easy and an interesting technique of logarithms. Thank you for joining me for this video. We have written over here the formula for change of base logs. Let's read it out. Log base a x is equal to log base 10 x divided by log base 10 a. If you look at a scientific calculator, there's a button here, log, and above that you have an exponential function which has a base 10 in it. It looks something like this, log, and then you have a 10 and to the x. What this means and tells you that the scientific calculators are by default, this right here is always a base 10. You're not looking at a scientific calculator and looking at anything else other than a base 10 log on that. But not every question is always in base 10s. You could have a question in some other base, and how could you evaluate it, especially if it was a difficult question to evaluate. Like if I give you a question like this, log base 10, let's say 100. We know this is easy. You can use the formulas. We know a to the y is equal to x, and you can easily do this. You have 10 to the y is equal to 100. Therefore, y is equal to 2. 10 squared is equal to 100. We can do this. And you could even do this on your calculator because your calculator has the base 10 logs. How about if I gave this question, log base 5, 2. Now how do we go about doing it? Well, you can simply look at it as 5 to the y is equal to 2, but what do you do from here? It's not like you're looking at something that's easy. You need a calculator which has a base 5, or do you, to calculate this? You don't necessarily need it. What you need is just a technique, and that technique is a change of base logs. So let's look at this technique. It's used for these type of situations where your calculator does not provide you that base and you still need to calculate something similar to that. We will examine this by means of two easy examples, because the examples of this type are not hard. They're easy no matter how you look at it. You just have to do it and get comfortable with the technique. Our first question is this. Let's just look at exactly what I written. Log base 5, 2. You have to evaluate it. How can we do this? Use a change of base. Convert it all into base 10s. You're going to do log base 10. This larger number will become your numerator, and log base 10, the base over here, will now become your denominator. In both instances, these become what you are doing the log of, and in both instances this base gets converted to base 10. So now what you can simply do is, on your scientific calculator, you can just hit 2 and you can log it, because we're invoking now the base 10 and the calculator is base 10. And then you can hit 5 and the log, and you can do 0.6989 and just calculate this, and we'll have a good answer. Your answer will be 0.4300676. But what does this answer mean? And that right there is the interesting part of all of this. This tells you if you had 5 and you raise it to the power of 0.430676, you'll get a value of 2. Why is that interesting? Because it's another way of determining an answer to this type of question, because there's a technique you can do to learn this in precalculus. The technique is utilizing natural logs. You can bring the x over here. You can do x natural log 5 is equal to natural log 2, and then x is equal to natural log 2 over natural log 5. Here we're doing algebraic manipulation using properties of logs. But if you couldn't do this algebraic manipulation using property logs, then your only other option is to use the change of base logs formula, as you see right over here. This next question is our last question. Not hard, but we will do it. We have log base, let's say 13 and 20. This is out of the jurisdiction of your scientific calculator, because this is based on log base 10s. What you do is use a change of base and make it into something for which your calculator can handle, and it'll be log base 10, 20. This is your upper number. This right here will become your lower number. Log base 10, 13. Now you can easily bring a calculator and just do 20 log, and you have 1.301, and then you do 13 log, because you've converted this question into base 10 logs. You have 1.11394, and then you can get a good answer over here. And your answer is 1.1679. What does this tell you? It tells you if you had 13 and you raise it to the power of 1.1679, you should get 20, and that would be true. Think about it. 13 to the power of 1 would just be 13. 13 to the power of 2 would be 169. But the fact that 13 to the power of 1.1679 is close to 20, you know it's going to be a value very close to 1, because 13 to the power of 1 is 13. And you have a value not too far away, 20. So you must be a value somewhere right here. 1.16179 makes sense. And it serves as a good check for you. this entire procedure here, this little mental work you're doing on the side, serves as a very good check. So all in all, these type of questions are good because they help you bypass the limitation of the calculator with regards to that base 10, the default base 10 that they have for the log function. Basically converting this question here with the base 13 to a similar question but having a base 10. At the end, all of this thing here evaluates to this value right here, and this is the answer you're really looking for. This part down here is just a mental check you're doing. So when you're given change of base logs, the value you get using the change of base, that's the value you present as the answer to the question that's being asked. And that is the closure of this video. I hope you found this useful. Thank you for watching. Stay tuned. Have a nice day.